Hi students. Welcome to Smart Tricks for Study channel. ಪಾರ್ಟ್ A, B ಮತ್ತು C ನಲ್ಲಿ ಬರುವ 1 ಮಾರ್ಕ್, 2 ಮಾರ್ಕ್ಸ್, 3 ಮಾರ್ಕ್ಸ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಯಶಸ್ವಿಯಾಗಿ ಮುಗಿಸಿದ್ದೇವೆ. ಈಗ ಪರೀಕ್ಷೆಯ ಅತಿ ಮುಖ್ಯ ಭಾಗವಾದ ಪಾರ್ಟ್ 5 ಅಂಕದ ಪ್ರಶ್ನೆಗಳ ಸರದಿ. ಈ ವಿಡಿಯೋದಲ್ಲಿ 2026ರ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಗೆ ಬರಬಹುದಾದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಶ್ನೆಗಳನ್ನು ಅವುಗಳ ನಿಖರವಾದ ಉತ್ತರಗಳೊಂದಿಗೆ ನಾನು ವಿವರಿಸಲಿದ್ದೇನೆ. ವಿಡಿಯೋ ಶುರು ಮಾಡುವ ಮುನ್ನ ಇಂತಹ ಇಂಪಾರ್ಟೆಂಟ್ ವಿಡಿಯೋಗಳಿಗಾಗಿ ತಪ್ಪದೇ ನಮ್ಮ ಚಾನೆಲ್ ಅನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ.
Let's start. Question number 37. Derive an expression for electric potential at a point due to a point charge. Answer. From figure. Q is point charge at origin O. R is distance between O and P. X is distance between O and A. Dx is distance between A and B. E is electric field due to point charge Q. Q naught is unit positive charge is equal to +1 coulomb. According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught, Q naught by x square. But Q naught is equal to 1. Therefore, F is equal to 1 by 4 pi epsilon naught, Q by x square. Mark as equation 1. Small work done in bringing a unit positive charge Q naught from A to B is dW is equal to minus F into dx. Mark as equation 2. Negative sign indicates that work is done opposite to the direction of electric field. Substitute equation 1 into we get dW is equal to minus 1 by 4 pi epsilon naught, Q by x square into dx. Mark as equation 3. The total work done in moving 1 c of charge from x is equal to infinity to x is equal to r can be calculated by using integration. Therefore, W is equal to integration infinity to r of dW. Substitute equation 3 in this equation we get W is equal to integration infinity to r of minus 1 by 4 pi epsilon naught Q by x square into dx. Take constant term common. That is, W is equal to minus Q by 4 pi epsilon naught integration infinity to r of 1 by x square dx. On simplification, that is, integration of 1 by x square is equal to minus 1 by x. Substituting in above equation, we get W is equal to minus Q by 4 pi epsilon naught into bracket minus 1 by x infinity to r. The above equation can written as W is equal to minus Q by 4 pi epsilon naught into bracket 1 by r minus 1 by infinity, where 1 by infinity is equal to 0. Then W is equal to minus Q by 4 pi epsilon naught into bracket 1 by r. But V is equal to W by Q, where Q is equal to 1. That is V is equal to W. The final equation will be V is equal to 1 by 4 pi epsilon naught Q by r. This is the expression for electric potential. Next. 38. Assuming the expression for drift velocity, derive the expression for conductivity of a material sigma is equal to ne square tau by m, where symbols have their usual meaning. Answer. Consider a cylindrical metal wire of length L and uniform cross-sectional area A. The conductor is connected to a battery as shown in figure. When a potential difference is applied across the ends of the conductor, an electric field E will be set up in the conductor. Due to this electric field, the electron drifts with a velocity Vd in direction to opposite to the direction of electric field. N is number of free electrons per unit volume. The number of free electrons for a given volume of a conductor is equal to N into volume is equal to NaL. Total charge passing through the conductor, Q is equal to NALE. The time in which the charges pass through the conductor, T is equal to L by Vd. Therefore, the current flowing through a conductor, I is equal to Q by T. On substituting Q values, we get I is equal to NALE by T. But L by T is equal to Vd. Therefore, the above equation is written as I is equal to NEA Vd. Mark as equation 1. Take A, this side. That is, I by A is equal to NEVD. But I by A is equal to J, that is current density. Therefore, we can written as J is equal to NEVD. But drift velocity, Vd. Vd is equal to E by M into τ. Now substitute in 2. We get J is equal to Ne into E by M into τ. Therefore, we can write as J is equal to Ne square τ by M into E. Therefore, we get J is equal to sigma E, where sigma is equal to Ne square τ by M. This is an expression for electrical conductivity. Next. 39. Derive an expression for the magnetic field at a point on the axis of a circular current loop using Biot-Savart's law. Answer. Consider a circular coil of radius r carrying a current I plane of the coil perpendicular to the paper. Let P be a point at a distance x from the center of the coil along the axis. R is radius of loop. O is center of loop. Small r is distance between dl and P. dB is magnetic field at P due to current element. According to Biot-Savart law, the magnitude of magnetic field dB is equal to mu naught by 4 pi into I dl sin theta by r square. But theta is equal to 90 degree, then sin 0 degree is equal to 1. Therefore, dB is equal to mu naught by 4 pi into I dl by r square. Mark as equation 1. From figure, small r square is equal to x square plus r square. Substitute in 1, we get dB is equal to mu naught by 4 pi into I dl by x square plus r square. Mark as equation 2. The direction of dB is perpendicular to the plane containing dl and r. On resolving the dB into two components, dBx is equal to dB cos alpha, its x component along x-axis. dBy is equal to dB sin alpha, its y component along y-axis. Thus, only the dBx components survive. That is, dBx is equal to dB cos alpha. dBx is equal to mu naught by 4 pi into I dl by x square plus r square into cos alpha. From figure, cos alpha is equal to r by small r. That is equal to r by x square plus r square to the power 1 by 2. Substitute in above equation we get dBx is equal to mu naught by 4 pi into I dl by x square plus r square into r by x square plus r square to the power 1 by 2. On simplifying, dBx is equal to mu naught by 4 pi into I dlr by x square plus r square to the power 3 by 2. Therefore, the total magnetic field at P due to entire loop is given by Integration of dBx is equal to integration of mu naught by 4 pi into I dlr by x square plus r square to the power 3 by 2. Therefore, b is equal to mu naught ir by 4 pi into bracket x square plus r square to the power 3 by 2 into integration of dl. But integration of dl is equal to 2 pi r, that is circumference of loop. Therefore, b is equal to mu naught ir by 4 pi into bracket x square plus r square to the power 3 by 2 into 2 pi r. On simplifying, b is equal to mu naught ir square by 2 into x square plus r square to the power 3 by 2. This is expression for the magnetic field at a point on the axis of a circular current loop using Biot-Savart's law. Next. 40. What is a wavefront? Derive Snell's law for a plane wave undergoing refraction using Huygens principle. Answer. The locus of points which oscillate in same phase is called a wavefront. 2. Let Mn is interface. N1 is refractive index of medium, 1. N2 is refractive index of medium, 2, here, N2 greater than N1. V1 is speed of light in medium, 1. V2 is speed of light in medium, 2. AB is plane wavefront incident on Mn. I is angle of incidence. R is angle of refraction. CD is equal to refracted wavefront. The distances BC and AD are traveled by light in same time, t. In a time, t, secondary wavelet from B falls on the surface Mn traveling a distance BC. Therefore, BC is equal to V1 into t. In time, t, secondary wavelet from A will travel a distance AD. Therefore, AD is equal to V2 into t. From the figure, angle BAC is equal to I and ACD is equal to R. In triangle ABC, sin I is equal to BC by AC is equal to V1t by AC. In triangle ADC, sin R is equal to AD by AC is equal to V2t by AC. Now, divide sin I by sin R, we get sin I by sin R is equal to V1t by AC into AC by V2t. Here, AC get cancel and t also cancels. So we get sin I by sin R is equal to V1 by V2. But V1 by V2 is equal to N2 by B1. Therefore, sin I by sin R is equal to N2 by B1. On cross multiplying we get N1 sin I is equal to N2 sin R. This is expression for Snell's law for a plane wave undergoing refraction using Huygens principle. Next. 41. What is a half-wave rectifier? Draw a neat labeled circuit diagram and input-output waveforms for half-wave rectifier. Explain the working of half-wave rectifier. Answer. The rectifier which converts only half cycles of AC into DC is called half-wave rectifier. Circuit diagram and input-output waveforms for half-wave rectifier. The circuit diagram is as shown in the figure. The AC to be converted into DC is fed to the primary, P, of the transformer. A diode, D, and load resistor, RL, are connected to secondary, S, of the transformer. During positive half cycle of AC, the point A is positive potential with respect to point P, then diode is forward biased and it conducts the current, the output is obtained across the load resistance. During the negative half cycles of AC, the point A is negative potential with respect to B, then the diode is reverse biased and it does not conduct the current. The output is not obtained across the load resistance. We get the output only during 1/2 cycles. Thus it is called half-wave rectifier. The graph of input AC and output DC is shown in the figure. Don't forget to subscribe the channel for more.